Another great secret on the ACT math test to save time is to know something about your special right triangles. One of those special right triangles is the 45-45-90, also called the isosceles right triangle. Remember that an isosceles triangle has at least two equal sides, so this one's right here, but a right triangle has a right angle in it, so this is always going to happen when you have a 45-45 right triangle. Obviously, these two legs have to be the same thing, so if this side is 4, this side is 4, but when you know the leg of a 45-45-90, the hypotenuse will always be whatever the leg is times square roots of 2. So this side right here is automatically 4 square roots of 2. And to see that, if we didn't know b for a second, we could have done the Pythagorean theorem to where we would have went 4 squared plus 4 squared equals b squared. And of course, 16 plus 16 equals b squared. Add those up and you get 32 equals b squared, and then that means b would equal the square root of 32, but that radical can be simplified. 16 goes in there twice, and that means that the square root of 16 right here is literally 4. Square roots of 2 comes along for the ride, and that equals b. It's just a shortcut, so we don't have to do this. Whatever the leg is, the hypotenuse will always be that leg times the square root of 2. It'll happen every time. So if we go to our next 45-45-90. We know it's 45-45 because of the two tick marks, meaning it's isosceles and it's a right triangle. This is a leg also, so the leg is 6 square roots of 2. They have to be the same thing. To find the hypotenuse, we need to take this leg of 6 square roots of 2 and multiply it by radical 2. And that scares a lot of people, but you can do it. You can take numbers times numbers and radicals times radicals. So this 6 is going to be multiplied times this 1 and get a 6. And radical 2 times radical 2 will be radical 4. But we just got to notice that there is a perfect square underneath this square root, so this is really 6 times 2, which is actually 12 in that case. So this side length over here was 12. And if we're given this right triangle now, it's 45-45-90. It's got a leg of 1/2. This is also 1/2. And we don't like to mix fractions and radicals together, so if we're going to take the leg times square root of 2, we're going to turn the square root of 2 into a fraction. So we'll put it over 1, and then we multiply that together, numerator times numerator. It will give us radical 2, and denominator times denominator is going to be 2 in that case. Here, now we got to go backwards, and they give us the hypotenuse. So to go back and find a leg, we're going to end up dividing by radical 2, which is easier than you think for this particular problem, because you're going to take 8 square roots of 2 and divide it by the square root of 2. And those cancel each other out, and this is 8, which a lot of common sense you can see. If this is 8 square roots of 2, this has to be 8 for that to work out in this case. And if we could just jump over to number 6 for an example, you see they give us the hypotenuse, and it is 45-45-90 because here's 90, and these arc marks mean that these two angles are the same. Well, since all three add up to 180 and this is 90, there's 90 left for the other two. They have to be the same, so they're 45 and 45. So what we have to do is we'd have to take 9 and divide it by radical 2. But the bad thing is you can't have a radical in the denominator, so we do a little bit of math magic, which is called rationalize this guy by multiplying it by the number 1 in the form of radical 2 over radical 2, because radical 2 was the problem. So we can get 9 square roots of 2 up in the numerator, and radical 2 times radical 2 is radical 4, which simplifies to be 2, so here is our final answer. So there are other math teachers out there who say instead of dividing by radical 2, you could just multiply by radical 2 over 2 every time. That is the same thing. So we would have got our answer, but it's whatever you're more comfortable with. So these side lengths are 9 square roots of 2 over 2. And they're both the same because this guy is isosceles. And what you'll probably see on the ACT is a question more like this, where they give you the diagonal of a square is 6 inches. So I'll put that in my picture. And remember, a square is a quadrilateral with 4 right angles and 4 equal sides. Well, when you have one of the diagonals, it splits it up into 2 isosceles right triangles. And this brother right here is the hypotenuse of that. So to find that, we could divide 6 by radical 2, or you could have taken 6 times radical 2 over 2. These are the same thing, but this one's just a little bit quicker because you're going to get 6 square roots of 2 over, remember there's 1 here, 2, and you just reduce 6 over 2 is really 3 over 1, so you get 3 square roots of 2 all over 1, and that is the side length, 3 square roots of 2. But they're all the same, and the question asks us to find the perimeter. I didn't really read it all the way through. I found the side length, make sure you read the question to find the perimeter. Adding 3 square roots of 2 4 different times, you just add them all up. You have 3, 6, 9, 12 total square roots of 2. So 12 square roots of 2 inches is our exact perimeter in that case. This video was about 45, 45, 90 right triangles. There's another special right triangle that you can click right here about 30, 60, 90s and learn another shortcut.